Right now, at this very moment, something enormous is moving toward you. Not a meteor, not an asteroid, not some rogue planet. An entire galaxy, 2 trillion stars, hundreds of billions of solar systems, and more dark matter than you can possibly imagine. All of it hurtling in our direction at 150,000 miles per hour. And here's the part that should really bother you. Most of the universe is running away from us. Space itself is expanding. Galaxies are separating, drifting further apart with every passing second. So why is this one coming closer? The answer involves an invisible structure so massive it controls the fate of entire galaxies, including ours, and most people have never heard of it. To understand why this is strange, we need a quick recap of something Edwin Hubble confirmed back in 1929. The universe is expanding. Every galaxy beyond our local neighborhood is moving away from every other galaxy. Not because they're flying through space, but because the space between them is stretching. It's like dots on a balloon. As the balloon inflates, every dot moves away from every other dot. This is normal. This is expected. This is the universe doing exactly what the Big Bang set it up to do. So when astronomers first calculated that the Andromeda galaxy, our nearest large galactic neighbor, is actually approaching us at roughly 68 miles per second, or about 150,000 miles per hour, the scientific community didn't panic, but they did ask a very serious question. Why? What force could possibly overcome the expansion of the entire universe and pull two galaxies toward each other? The leading answer involves something you cannot see, cannot touch, and cannot directly detect: dark matter. Now, dark matter is one of those terms that gets thrown around a lot in science videos. So let's be precise about what we actually know. Dark matter doesn't emit light. It doesn't interact with electromagnetic radiation at all. We can't photograph it, X-ray it, or shine a laser through it. The only reason we even know it exists is because of the gravity it produces. Gravity strong enough to bend light, to hold galaxies together, and apparently to pull entire galaxies toward each other. Recent research suggests that the Milky Way and Andromeda aren't just floating freely in space. They both sit inside an enormous flat structure, a vast sheet of dark matter, sometimes called a cosmic sheet. Think of it like this. Imagine a giant invisible trampoline stretched across millions of light years of space. The Milky Way and Andromeda are both sitting in this trampoline, and just like any two heavy balls on a shared trampoline, they naturally roll toward each other, pulled together by the curvature created by that shared structure. The gravity of this dark matter sheet doesn't just explain why Andromeda is coming toward us. It may explain the specific speed and angle of its approach in ways our old models couldn't quite account for. And then there are the voids. Between the great filaments and sheets of the cosmic web, there are vast, nearly empty bubbles called cosmic voids. These are regions of space where matter is astonishingly sparse, and they're not passive. They're relative emptiness creates a kind of outward pressure on the matter around them, pushing galaxies and clusters toward denser regions. Think of it like air pressure. High pressure pushes toward low pressure. Dense cosmic structures push toward other dense structures, shepherded by the emptiness surrounding them. Together, the dark matter sheet pulling, the cosmic voids pushing, it creates a perfect gravitational funnel directing Andromeda straight toward the Milky Way. So the collision is coming. In approximately 4.5 billion years, Andromeda will arrive, and here's where most people's imaginations go to a scene of absolute destruction. Star crashing into star, solar systems obliterated, everything reduced to cosmic wreckage. But that's not what's going to happen. And the reason tells us something profound about the nature of galaxies themselves. Galaxies are almost entirely nothing. The distances between individual stars are so incomprehensibly vast that even when two galaxies pass through each other, the probability of any two stars directly colliding is almost zero. Our nearest stellar neighbor, Proxima Centauri, is about 4.2 light years away. That's roughly 25 trillion miles. If you shrunk the sun to the size of a grapefruit, Proxima Centauri would be another grapefruit sitting in Tokyo, if you're in New York. Galaxies are mostly ghost towns with very spread out houses. Two ghost towns can merge without the buildings ever touching. But that doesn't mean the merger will be gentle. Gravity, on the other hand, reaches everywhere. As Andromeda approaches, its gravitational pull will begin distorting the outer arms of the Milky Way. Long tidal streams of stars will be ripped outward and flung across hundreds of thousands of light years. The spiral structure of both galaxies, those beautiful, elegant arms you see in photographs, will be twisted, shredded, and scrambled beyond recognition. Clouds of gas and dust will be compressed compressed as they collide. And compression means heat. Heat means star formation. The collision is expected to trigger massive bursts of new star formation. Baby stars being born by the billions, lighting up regions that were previously dark and cold. And then there are the supermassive black holes. Both the Milky Way and Andromeda have one at their centers. As the galaxies merge, those black holes will eventually find each other, orbit one another for hundreds of millions of years, and finally merge into one absolutely colossal black hole at the center of the new combined galaxy. Scientists have a name for what this merged galaxy will eventually look like, and it's wonderful. Milkdromeda. Milkdromeda will likely be a giant elliptical galaxy, not a graceful spiral like the Milky Way, but a massive rounded cloud of stars, ancient and enormous. The remnant of two galactic civilizations fused into one. As for our solar system, Earth, if it still exists, will almost certainly survive the merger. We may be flung into a new orbit, perhaps closer to the galactic center, perhaps further out, but the sun will keep burning, the planets will keep orbiting. Life, if it still exists here, might look up at a night sky blazing with twice as many stars. A sky so bright some nights might barely get dark at all. Now here's where things get genuinely strange, and honestly, a little controversial. We've been talking about dark matter as a large-scale structure, but some scientists are beginning to ask whether dark matter isn't just around galaxies, but inside them too, specifically at their very hearts. The center of the Milky Way is occupied by something we call Sagittarius A star, an object roughly 4 million times the mass of our sun, crammed into a space smaller than our solar system. The standard scientific consensus is that this is a supermassive black hole, and the evidence is compelling. We've watched stars orbit it, and we even captured its first image in 2022. But a small number of researchers have floated a genuinely radical alternative. What if it isn't a black hole? What if the object at our galaxy's center is actually an extraordinarily dense concentration of dark matter? A dark matter core so tightly packed that it mimics the gravitational signature of a black hole perfectly. Now, to be clear, this is a minority view. Most physicists are confident SGRA star is a black hole. The evidence is strong. But the very fact that a dense enough dark matter structure could produce nearly identical observable signatures is unsettling. It means our tools for distinguishing the two may not be as sharp as we'd like. And it raises a broader question that's increasingly hard to ignore. How much of what we think we understand about galaxies, their formation, their structure, their motion, is actually the shadow cast by something we can't see at all? Dark matter makes up roughly 27% of the total energy content of the universe. Ordinary matter, everything you can see, touch, breathe, measure, everything made of atoms, adds up to just about 5%. The rest, dark energy. Another mystery entirely. We are, in the most literal sense, made of the minority ingredient. The universe is dominated by things we cannot directly observe, whose nature we don't fully understand, and whose behavior shapes everything. Where galaxies form, how they move, when and how they collide. The Andromeda collision isn't just a spectacular cosmic event 4.5 billion years in the future. It's a story written in dark matter. An invisible hand drawing two galaxies together across the void. We started this video with a simple question. Why is Andromeda coming toward us when everything else is running away? And the answer turned out to be a story about invisible structures controlling the fate of galaxies. A cosmic collision that will reshape our night sky, and a universe that is overwhelmingly made of things we've barely begun to understand. The collision won't happen for another 4.5 billion years. But the dark matter causing it, it's already here, everywhere, right now. Makes you look at the night sky a little differently, doesn't it? Drop a comment below and tell me, if you could watch the Andromeda collision from Earth billions of years from now, would you want to? Yes or no? I read every single comment. Hit subscribe if you're new. We go deep on the science here every single week. And if you want a head start before the next video drops, the notification bell is your friend. I'll see you in the next one.